Good afternoon and welcome to this webinar, How Advanced Work Packaging Drives Next Generation Project Management. This event is brought to you by Engineering News Record and sponsored by InEight. Hi, I'm Scott Seltz, publisher of ENR and your moderator for today's presentation, and thank you for joining us. Advanced work packaging is being touted by many as next generation project planning, for good reason. AWP is equally relevant to both owners and contractors, driving a more collaborative and transparent approach to executing projects. This webinar details how organizations can excel at AWP-driven projects to ensure more on-time, on-budget project successes. Today's presenter is Dr. Dan Patterson, Chief Design Officer at InEight. As a globally recognized project analytics thought leader and software entrepreneur, Dan Patterson has more than 20 years of experience building project management software companies. He founded Basis, a company that developed an artificial intelligence planning software tool that was acquired by InEight in 2018. Following that acquisition, Dan became a member of InEight's executive leadership team, now focuses on expanding upon his vision of creating next-generation planning and scheduling software solutions for the construction industry. Now, before we begin today's presentation, please enjoy this brief instructional video on how to use your webinar console.
Welcome to this webinar. Before we begin the presentation, I want to provide you with a few housekeeping items. On your screen, you will see a taskbar with icons. Each icon is assigned to a particular element of today's webinar. Click on the person icon to learn more about today's speakers. Throughout the presentation, you can network with others, or submit questions to the speakers in the Q&A and chat box next to the slides. Download resources from the cloud icon. After the webinar is over, please take our survey to tell us how we did. Today's event is being recorded and archived and will be available within 24 hours. For on-demand questions or comments, send us an email by clicking Need Help? Email us. If you experience any technical issues today, please refresh your browser by hitting F5 for PC or Command R for Mac. And now I'm excited to turn it over to today's moderator.
Don't forget to submit your questions during the presentation, and later in the program, our presenter will address as many as possible. Today's event is being recorded and archived at enr.com/webinar, so you can share this presentation with your colleagues. And now, I'm excited to turn it over to today's presenter, Dr. Dan Patterson. Dan?
Well, thank you very much, Scott. I am extremely excited to be here today. So once in a blue moon, along comes not only a new technology, but also a new way of thinking with regards to solving a problem. And relating that back to project planning, I genuinely believe that that point in time is now. And so today, I'm going to share with you what I believe to be the magical marriage between AI technology and an emerging planning technique known as AWP, or Advanced Work Packaging. Now, just taking a step back for a minute, when we think about capital expenditure projects, they are, obviously by definition, they're a unique endeavor. They're instigated by an owner organization. That owner organization then carries the burden of the investment risk, but yet the outcome of that CapEx project is actually largely in the hands of the contractor. So it's a very unique situation with regards to balance of risk between the owner and the contractor. And again, when we dive a little deeper, when we look at the risk exposure from the contractor perspective, the contractor is carrying a huge amount of risk burden, not only during the execution phase, but actually during the bidding phase itself. If in many ways, it's worse to win an uncompetitive bid than it is to not bid in the first place. So I would suggest over the last 40 years or so, CapEx projects have really on what has largely been an unchanged approach or techniques pertaining to project management. And yet the historical track record of these projects, honestly, I think has been pretty dismal. And so because of that, I think there is now a long overdue need for a better, more effective and predictive means of forecasting CapEx projects. So that really leads us into next generation planning and an introduction into this concept of advanced work packaging. So traditional planning philosophy, very, very simple. We've historically planned from left to right. What I mean by that is we establish a project start date, and then we develop a sequence of work, starting with design and engineering. We then detail out our procurement and fabrication. And finally, we then start to consider our construction scope. So it's very much a left to right concept with regards to forecasting. And as a result of that, as we all know, we then focus on what we call the critical path. Now, again, I think that's been certainly an effective way of planning over the years. But one of the downsides to that is what I describe as compounding delay effect. In other words, you may have the best execution or the best construction plan laid out, but that construction plan is essentially being held hostage by any form of preceding delay that may occur way upstream in the engineering and or the procurement phases of the project. So as a result of that, this compounding delay and risk exposure, by the time it gets to execution and closeout, that project completion date and forecast cost becomes highly uncertain. So AWP, or advanced work packaging, and we'll get into the details of this in a few minutes, but AWP really turns that left to right thinking on its head, and instead we actually start to plan from a defined, definitive project completion on the right-hand side, and we work backwards. I think, again, one of the biggest differences between AWP and traditional planning is we are focusing on the execution phase. Again, traditionally, project management was really segmented into plan the work and then work the plan. AWP is very different. Everything we do, whether it's pre-concept, concept select, project sanction, early stage planning, everything and everybody associated with developing that forecast is 100% focused on execution and ensuring that execution is what we call constraint-free. Now, many people describe AWP as the alignment of people, materials, and space. The right people arriving at the right time with the right materials in order to execute the work. And I think that alignment concept is very, very important. I do, though, believe that the biggest benefit of AWP is the driving and the focus on forecast certainty. Again, traditional planning, putting together what we call a CPM schedule, is not by any means the most likely outcome. I actually believe it is the best case scenario. In risk terminology, we call that your P0. Well, going into execution, trying to achieve the best case scenario, you're going to fail. Surely we should be planning to at least the most likely scenario, taking into account, for example, quantity growth and potential downside, uncertainty of scope, potential discrete external risk events, so on and so forth. If we account for those up front during the planning phase, then we have a much higher probability during the execution and construction phase of a project of achieving that forecasted duration. So AWP in many ways is driving us to start thinking about planning to the most likely rather than simply planning to the best case scenario. So let's have a little survey for a second. So, again, AWP is very much about planning from right to left. How many of you today, irrespective of whether you're using or adopting AWP, are actually planning from right to left rather than left to right? And whilst the results are coming in, I can share with you all that in recent months, discussing with both owners and contractors, while AWP is certainly early stage, emerging, I would almost call it the Wild West. We still have a lot of maturity to go with regards to formulating exactly what AWP is. I think it's fair to say that a lot of projects today actually do think in terms of planning from right to left. Now, it's interesting, the results that are coming back here, 2/3 of you are saying no, we actually plan in the traditional left to right. I think what would be potentially more interesting is also to understand whether those of you that are planning from right to left, are you a contractor or are you an owner? So touching on the formal definition of AWP, so organizations such as CII have a very thorough formal definition of AWP. So I'm not going to read this word for word, but they talk about a process flow around all the detailed work packages. It's a planned executable process, blah, 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 blah. It provides a framework for productive and progressive construction. In my opinion, that's a lot of words for let's focus on enabling constraint-free execution. At the end of the day, if, again, the right people and the right materials are present at the right location during execution, there is no valid reason why productivity shouldn't be what we planned it to be. There is no reason why that project should not execute exactly as per plan. So I think of AWP as a shift and a pivot towards 100% laser focus on planning for execution. I think in addition, one of the very exciting aspects of AWP is for the first time in project management history, we are now marrying together what I think of as front-end planning and work phase planning. So front-end planning is your early stage planning. Your work phase planning is then in the field. Aligning and bringing those two together, I think, is a massive step forward. So again, from a lot of articles that have been recently written, some of the benefits I think are fairly obvious. So obviously, anything in our industry that reduces cost and schedule on a project is a good thing. I think what's interesting about AWP is we're actually starting to get some hard and fast metrics with regards to return on investment. And in fact, projects that are undertaking AWP today are actually reporting back a reduced installation or execution cost of up to 10%. Well, that's obviously a very significant and material metric. Likewise, with regards to productivity, being able to increase labor productivity by as much as 25%. Now, I would throw a little caution to the wind there. That 25% increase in labor productivity is probably not 25% better than planned. You're just eliminating the fact that typically you're going to be 25% slower than planned. I think ultimately the benefit of AWP, so again, it's all down to improving predictability. In a traditional planning and scheduling environment, you can make the project completion date and that target cost whatever you want it to be. You can effectively adjust the many levers and variables that you put into a forecast to get the answer that you want. However, that answer doesn't come with a given degree of confidence or predictability. Conversely, AWP is absolutely driving the predictability and our confidence level. I would much rather go into a project knowing that I have arguably a longer duration than I'm perhaps comfortable with if I have a very high degree of confidence that I'm going to hit that. So again, a lot has been talked about with regards to AWP driving project alignment. The age-old triple constraint of aligning time versus money versus quality, I think, is important. Alignment between engineering, procurement, construction. I think this is interesting in that, again, traditionally, the engineering scope, the procurement scope, and certainly the construction scope has been planned by three separate parties with arguably limited interaction and interfacing between them. Alignment between the outcome prediction and outcome reality. This is my favorite because, again, what we're doing here is we are aligning our forecast with reality, which is the execution phase of the project. Whatever we can do to increase the achievability of the plan, that's our prediction, has to then subsequently benefit us when it comes to execution and driving a more on-time outcome reality. So, again, I can't stress enough the benefit of alignment that AWP brings to the table. And also, and it's not mentioned on this slide, alignment between the owner organization and the contractor organization as well. Okay, so let's dive a little deeper now into how do we actually walk through and implement the AWP process. So this graphic on the screen here is a two-dimensional graphic. So first and foremost, again, I think it's very important to understand we plan from right to left. So in my example here, we have an energy project where we have a combined scope, where we have an onshore facility, we have an offshore environment. Both of those sub-projects have to be completed in order for the onshore refinery to be started up. We have to have the material being brought in offshore, and then we have an offshore startup campaign leading to onshore startup. Now, I think what's interesting and important to note about AWP is when we define our top level entity, and we call that path of construction, that top level entity doesn't just focus on what we used to think of as the critical path items. In my example, the onshore commissioning actually has a huge amount of float relative to the onshore scope, but that onshore commissioning is mission critical as part of the startup sequence of the overall plant. So again, it's a mindset change. It's not like the old days where we would arguably blindly just focus on the critical path and not worry so much about the elements carrying float. We absolutely now do take into account those scopes of work that carry float. And I think that's important because in many instances, those float carrying scopes of work as a result of risk can actually become critical themselves. So again, planning from right to left, and then on the vertical axis, what we're really doing is we're taking a very high level entity, this level 1 path of construction, and we're disseminating it down, not only through the planning phase, so what I call front-end planning, down to, and again, we'll elaborate in a few minutes on some of these constructs, but going beyond just the front-end planning, but then actually throwing this plan over the fence to the field where we get into work phase planning, all the way down to literally daily or even shift-based planning. So the 5 levels here, level 1, path of construction, we have what we call construction work areas. We then have work packages, installation work packages, and then daily plans. So let's take a look at each of those in sequence. So path of construction, or POC. So again, this is really a logical sequence of the key deliverables required to support our startup and handover back to the owner organization. And again, it's not just the critical path. So think of the path of construction as very large elements. And really what we're doing is we're setting in stone, or we're baselining those elements. So everything we subsequently plan and detail out, we then have a benchmark or a baseline against which we can measure. So from an owner perspective, this is hugely powerful because as execution is carried out, we can monitor the contractor's performance relative to these high-level, big-picture path of construction blocks. And again, from a contractor perspective, we can ensure things like timely payment because we're in alignment with these big entity blocks. Now, at InEight, we're actually leveraging artificial intelligence, or AI, to assist with this path of construction plan development. So just a very, very quick primer on artificial intelligence. So, in simple terms, AI is really all about the ability for a computer to understand and deduce and make intelligent decisions as per a human. So the way we're embracing AI at InEight, we're actually, I would suggest, somewhat humble in our description of AI, in that we believe AI to be more augmented intelligence rather than artificial intelligence. I absolutely do not believe that a computer can take over the experience and the expertise of a planner or a scheduler or a cost estimator. I do passionately believe, though, computers are very good at some of the tedious tasks, for example, mining data. And so if the computer is smart enough to start making suggestions through pattern recognition and mine very large quantities of historical project information and make suggestions back to me so that I can adopt those in my plan, that has to be a good thing. So that's exactly how we are embracing AI. We have what we call a knowledge library, where a project or an organization can store what we call unstructured data. So that unstructured data can be historical Primavera P6 schedules, Excel cost spreadsheets, risk registers, productivity rates, so on and so forth. And then we have what we call an inference engine. This is the smarts, the brain, whereby the computer goes off and mines and interrogates that knowledge library. And what it's trying to do there is come back with analogous matches so that it can make intelligent suggestions back to the project planner such that he or she can then adopt them into the plan. So again, relating that back to the development of the path of construction, because these are such high-level building blocks, this is a perfect use case for leveraging AI. So the example on the right-hand side here, all the planner has to do is give the computer some degree of context when doing their top-down path of construction development. So for example, tell the computer the type of project, tell the computer the geographical location, what are the current commercial market conditions with regards to availability of subcontractors. So based on those points of context, that gives the computer enough information then to go off and start coming back with calibrated suggestions for those big picture building blocks in the form of our path of construction. So another survey question. This concept of AI, really what it's doing is, yes, the computer's making suggestions. I see AI as like next generation benchmarking. It's in real time, it's critiquing your schedule and validating and calibrating. So the question here, I'm sure the answers are going to be a resounding yes, and I can see it's about a 90% yes. Again, I'd be interested in chatting with the 10% knowers, because I think one of the challenges of AI and knowledge-driven planning is, you have to have some degree of historical information as an organization in order for AI to be useful. And again, we're coming up with techniques to make it easier to scrape that historical information and not only capture it, but then subsequently mine it as well. So think of AI really as kind of next-gen benchmarking. So now we get into what we call construction work areas. We've defined our path of construction. In the non-technical term, I call this chunking, because what we're doing is we're chunking that path of construction into manageable geographical areas of work. So this could be, train 1, train 2 in a refinery. It could be east versus west on a linear road project. These construction work areas, they're multidiscipline, and typically, again, they're very, very high level. And I think one of the benefits of AWP is there is a huge drive to visualize this top-down plan. So the example on the screen here, we're using a model viewer to not only render the 3D representation of the asset that the project is building, but more importantly, we can now start to highlight and light up the different sections of the project. In this case, we're highlighting a specific construction work area. Now, I think where this becomes even more useful, or this concept of visualization through model enhancement becomes even more useful, is at the third level, when instead of looking at those big picture path of construction elements and those segments, those big picture elements are really scope. They are the deliverables that the owner is going to receive. Now, when we get down to what we call the construction work package, or the CWP level, we're kind of flipping this on its head. Now we get into the work. This is the stuff that the contractor has to execute in order to deliver what we saw previously with our path of construction elements. So these CWPs are they're level 3 in a CPM schedule, typically no more than 40,000 man hours. And I think what is so key and important to note here is there is very little value in detailing out your schedule down to the CWP level until you are no more than 3 months or 90 days out from the execution itself. The reason being, there is so much variability beyond that 90-day window that you're effectively, you're to a degree wasting your time getting down to this level of detail until you have that 90-day lookout. The other thing I think that's great with regards to AWP is because we're able to visualize our CWPs, our construction work packages in our model here. Remember, our path of construction was perhaps our 10 or 12 big picture elements. As we're sequencing out the work, as you can see in the top right in the Gantt chart, as those CWPs get developed, if they breach the big bucket path of construction elements, the model can automatically light up and show you that the contractor's perception as to when they're going to do the work and how much work they've got to do doesn't align with the owner's view of the project. So it becomes a very, very powerful reporting mechanism as well. You might be wondering, well, okay, we've dived straight into execution scope. What happened to the engineering and procurement stuff? Well, by design, if you remember, AWP is all about start with the end and work backwards. So we are absolutely detailing out our construction work packages before we then take a step back and say, okay, what do we need to do and when do we need to do it from a procurement and an engineering perspective to support constraint-free execution. So talking of supporting elements, engineering and procurement work packages. I think of this as kind of like backfilling the construction work packs. Think of this as what are the need dates of those CWPs that we just defined previously. So again, this is so different to traditional planning, whereby when we started from left to right, and then we'd have this compounding knock-on effect of uncertainty as we go from engineering through procurement construction, we're turning it on its head. We're saying, no, execution is what it is. Let's work backwards. And not only that, let's start to add float and contingency to those supporting engineering and procurement elements, such that if there is a potential delay in, let's say, fabrication and delivery of a long lead item, we are still upholding that constraint-free execution. Now, this concept of backfilling and identifying and supporting these need dates, at InEight, we've come up with this concept of rules of thumb. So rules of thumb really pertains less to planning appropriate durations, but more about getting the sequence of events correct. So to give you an example, perhaps on a concrete pour, obviously we need things like rebar in place in order to start the concrete pour. Well, from a fabrication perspective, we don't need every single piece of rebar present on site to start some of the early concrete pours. So having these rules of thumb where, for example, let's say 60% of the material delivery needs to be present on site in order to start a particular execution piece of work. So this concept of rules of thumb is very, very important. And again, leveraging AI to go back and look at historical projects and say, okay, well, did we have sufficient lead time on those deliveries? Was the corresponding execution scope on time, or indeed was it delayed? So the example on the screen here shows not only a CPM schedule that has the construction and the procurement and the engineering work packages, but the green shading behind each of those elements is it's reporting the correct overlap or rule of thumb and sequence of those elements. So again, I think that's really, really powerful insight, because historically, construction and execution always gets the blame for late project delivery. In reality, it's rarely the fault of execution. It's the fact that execution is held up by upstream delays. So everything we've touched on so far has really focused on what I call front-end planning. But again, it's front-end planning in order to support execution. So at this point, and if you remember, there was sort of a above the fold and below the fold dotted line on that AWP schematic. What we're doing now is we're starting to look at actual field execution. So field execution, we take those construction work packages and we break them down yet again into a further level of detail. Those level of detail elements are known as IWPs, or installation work packages. So what we're doing here is we're not just detailing out how long the work should take, we're also capturing and bringing together the man hours required, the crews that are required, and probably more importantly, the materials and the components that those crews need in order to do the execution and or the installation. So again, what I think is really valuable here is we're now starting to take into account quantity and quantity growth and apply that to our very detailed daily planning. Now, what we're looking at here is an example where a foreman has an iPad. Yes, they're able to see the work that they're being asked to do, or that their crew are being asked to do on a particular day. But more importantly, they get insight. You can see here installation quantity. They can actually track how much they installed versus how much they were forecasted to install. So this goes well beyond traditional, CPM status capture, where we would perhaps just report % complete. This is truly capturing the value of work that is being installed. So this actually kind of bleeds into the science of earned value, where we're looking at not only the work expended, but the value that we're bringing to the table as a result of expending that work. And then finally, taking the concept of field execution planning down to the utmost level of detail, this is where we get into what we call short interval planning. And again, this is a relatively new science, and I truly think this is going to, at worst, make a dent, at best, revolutionize how we execute projects in the field. Because what it does, it takes those bigger picture activities or IWPs, or even at a higher level, those construction work packages that we modeled in our CPM schedule. You can see those represented as the blue horizontal lines in this chart. And again, then the foreman or the superintendent can detail out these short interval daily plans. But again, what's super powerful here is the computer is suggesting a given duration based on the CPM schedule. The foreman then simply has to plug in the quantities of components and or work that is being required. Computer then will calculate, based on historical productivity rates that were achieved, how many days in reality it will actually take to execute that work. Now, the value here, and you can see this sort of halfway down the screen, we've got a cross haul. This is a mass haul earthworks activity. The 2 days allocated for cross haul are actually highlighted in orange. What that's saying is that the foreman for the earthworks scope here is not in agreement or in alignment with CPM planner or scheduler that put the bigger picture plan together. So who wins? Well, in reality, the foreman's going to go out and do what he or she believes is best. That's great. The power here, though, is that misalignment, that breach, can automatically feed back into the CPM schedule. What does that mean? That means the owner then gets in real time, or a much more up-to-date view as to how that CPM schedule is changing, and ultimately whether or not they need to start being concerned about a project completion slip date. So again, this is another mechanism for ensuring this concept of constraint-free execution, which is really the backbone of AWP. So in one of the earlier introductory slides, I mentioned the concept of planning to the most likely rather than our traditional approach of hoping that we can somehow magically achieve the best case scenario. So that gets us into the world of risk management, or risk analysis, or if you like, risk intelligence. Now, again, risk management is certainly, when it comes to scheduling and cost forecasting, is not by any means a new science. That was really brought to the masses, I would suggest, 15 years ago with the introduction of Monte Carlo analysis type tools, where you would take, again, for example, a Primavera schedule, and you would go through the very tedious and statistically painful process of taking durations and costs and trying to link or model what we call a 3-point estimate. So, okay, a 20-day duration, what is the minimum, the most likely, and worst case or maximum associated duration with that 20 days? That would form a range. The computer would then run a simulation. The computing bit was relatively easy. It's just number crunching. It's mathematics. What has proven to be really difficult to date has been the objective inputs from team members. Project team members and stakeholders, they don't care and shouldn't care about, triangular distributions and uniform distributions and trigens and correlation. They just want to be able to execute the project with a high degree of confidence. Well, what we're now doing with AWP is we're bringing together the science of risk analysis and CPM scheduling such that in real time, again, as you build your plan and you define your CWPs and the supporting engineering and procurement work packages, and you break those down into installation work packages, if the team members can collaborate and provide feedback, then those differing opinions actually themselves form the input for those ranges. So the example on the screen in the top right corner, there are 3 competing or differing opinions as to what the duration of a particular element should be. That's absolutely fine, because those differing opinions, like I say, they form the input into your risk range, such that then the computer can generate on the fly what we call a risk-adjusted forecast. And again, while it's taken almost 2 decades, I am very excited about the fact that finally projects are starting to understand, okay, a forecast is one thing, but let's forecast within the context of a given confidence level. So when we put our cost and schedule forecast together, let's tie perhaps a P75, or let's go with it. If we're risk averse, we probably would go with more like a 90% certainty with corresponding contingency. If we are more of a organization willing to take on a little bit more risk, then let's go with maybe a P50 or even a much more aggressive P25. But having an associated confidence level with our forecast, it gives us another dimension against which we can make intelligent decisions as to, do we even pursue the project in the first place. So an example here where, here's our non-risk adjusted view of our AWP schedule. And then in the context of applying discrete risk events and team members' expert opinion, you'll see the schedule not only shifts to the right, but remember we talked about those rules of thumb and the alignment between the execution and the procurement stuff. The orange highlighters here are actually telling us now that actually these procurement elements, while the durations are appropriate, those procurement elements are going to get delivered too late in order to support constraint-free execution. So on the screen here is a very new concept. This is what I'm going to call this a risk-adjusted path of construction. And what it is, it goes back to that level 1 construct that we developed all the way back in the first stage of our AWP development. And the thin horizontal bars here are those path of construction elements. So again, we have onshore scope in sort of the turquoise color. We have offshore scope in the orange, and then those two come together with the startup campaign in that dark red. So without taking into account the risk-adjusted view of the project, the onshore construction scope actually has a degree of float. In fact, there's about a month and a half float. And it's because once the offshore scope is complete, there is a startup campaign that is needed for offshore before offshore can hook into the overall onshore startup campaign. So on paper, it looks as if the onshore part of this project is the least risky part of the project. There's a month and a half worth of float. That's absolutely great. It's not great. The reality is this. When the project in question conducted a risk analysis using the technique that I showed on the prior slide, the confidence level in achieving that onshore construction completion was actually very, very low. And in fact, it was worse than that. There was only a 50% chance that the onshore scope would finish before the offshore scope. So what did that mean? It meant there was more than 50% chance that the onshore scope was going to drive the overall project. So it was a hidden bottleneck. It was a hidden critical path in that overarching path of construction. Again, this concept of marrying together the path of construction, which is our project target, and then backfilling that with the risk-adjusted view of how the contractor is actually going to execute, and comparing the two is just so powerful. So when people talk about AWP, it's rare for them not to mention either this concept of a digital thread or a digital twin. And again, I think these are both secondary benefits that come about as a result of embracing AWP. So let's start with digital thread. So the formal definition of a digital thread is it's a record of a product or project timeline. It represents work being executed. So again, because we started with level 1 and then we broke it down into construction work packages and IWPs, in each of those steps, it wasn't just the record or the recording of duration and time. As you previously saw, it was capturing required quantities, it was scope, it was risk events. All of the variables that drive execution are being captured through the AWP process. And so if they get digitally captured in the form of what we call a digital thread, that is in essence a record of how the contractor executed the work. Now, a digital thread, I think, is very valuable from now we can use that in terms of lessons learned and look back over those productivity rates, etc. But it's useful or more useful to a contractor. Conversely, for the owner organization, they ultimately care about the thing that's being built, the asset in which they invested during their CapEx expenditure of the project. So from an owner perspective, they care more about what we call a digital twin. So a digital twin is an electronic representation of the asset. So that could be in the form of 2D plans, 3D drawings, spec sheets. It's less about how the project was executed and more about the deliverables that the contractor gave and threw over the fence to the owner during handover. So here you have a double benefit. The digital thread gives you a record as to how the project was built and how it was executed. The digital twin is an electronic representation of the asset itself. Now, why are these both together useful? I think during the operational life of the asset itself, the digital twin and the digital thread combined give us insight that we didn't have before as to, okay, when should we schedule maintenance, or when should we do our, what's the cadence of our planned shutdowns or turnarounds? So, again, if there were issues during the installation campaign, they'll be captured in the digital thread. If there are performance issues with regards to the asset, they're captured in the digital twin. And bringing that information together, again, I think it's so valuable, not necessarily just during the project life cycle of the asset, but during the operational phase of the asset itself. So moving towards wrap up, just some comments and maybe some things to think about beyond the seminar today. I think it goes without saying that AWP absolutely aligns the contractor's ability to execute with the expectations that the owner has. And anything we can do as an industry to break down, this firewall between owner and contractor and align those expectations has to be a good thing. Take the AWP acronym literally. There's a reason why it's called advanced. It's an advanced way to plan. It's next generation planning. The fact that it focuses on work, it's the work required during execution. Again, it's gearing all stakeholders during the planning process to focus on supporting constraint-free execution. And again, thirdly, the concept of packages. It's bundling stuff and breaking down scopes of work into manageable, in this case, packages. So it's funny, you pick up a project management textbook, and almost without exception, every introductory chapter talks about project management is all about planning the work and then subsequently working the plan. AWP is different. It turns that on its head. I see AWP as it's constant planning throughout the project lifecycle, so we are better planning the plan so that we can better work the work. Again, it's focusing everybody on being able to execute rather than the old-fashioned way of, well, we'll focus on planning and then we'll switch over to execution mode. You have to plan and replan even during execution. And I think, there's been question as to why now. I think why now is been driven by, I think the industry has got to the point where, the horrible track record of CapEx projects just isn't acceptable anymore. But I think, now we are able to tackle that poor track record through the advent of technologies such as artificial intelligence, or I would suggest augmented intelligence. Computers are finally powerful enough, and computing power and storage is so ridiculously cheap these days that we can intelligently mine vast historical data sets without them being highly structured. So AI is absolutely a game changer and an enabler to what I believe to be next generation planning in the form of AWP. So with that, I think I'm going to hand over to Scott, and we'll have some Q&A.
Thank you, Dan. That was a great presentation. Before we have you address some of the questions that have been submitted throughout the program, I wanted to remind our audience that we'd love their feedback in our webinar survey that will be offered at the conclusion of the event, which will help us improve our program. So I know we did get a lot of good questions coming in, but before we go to those questions, I actually have two as a result of your presentation, Dan. The first question, excuse me, is do you think AI will replace the expertise of the planner cost estimator?
If you read a lot of media articles, the answer is yes. The honest reality is no. Computers are highly powerful, but when you break them down into the only fundamental task a computer can do is add things together. They can learn and they can be taught. They augment a human's ability to make a decision. So no, AI will not replace humankind, and it certainly won't replace the expertise of planners and cost estimators and project stakeholders. But AI it's a game changer. Like I say, it's allowing and enabling, for example, me as a planner scheduler to focus on what I'm good at and let the computer do the hard work of mining that historical information.
And you touched on this at the very beginning of your presentation. But does AWP turn traditional CapEx planning on its head with this whole plan right to left approach?
Yes. I mean, obviously, the mentality of planning right to left is, of course, different from left to right. I think, though, while AWP is a sound methodology, I think it's important to note that a lot of projects are doing parts of AWP. They may not be, purely following the methodology in its entirety, but the concept of taking a level one and breaking it into areas and then work packages, installation packages, I think is somewhat commonplace. I think also, I talked a little bit about this concept of constraint-free execution. What I should have mentioned earlier was when we talk about constraints, we're not talking about traditional CPM constraints where you put in a cannot start earlier than type date. The constraint-free concept in AWP is all about, again, do I have the right people in the right place at the right time with the right materials in order for them to execute their work?
That's good, because we did have a question from the audience already that wanted to understand what you meant by constraint-free. So that was a twofer question. Going to the audience and our viewers, David Stone asked, how does AWP differ from pole planning, earlier packaging of work?
Okay, so there are actually, I would say, close to half a dozen, not competing, but in many ways similar emerging planning techniques. So there's Lean, there's Last Planner, there's one in Europe that's taking off right now, Pact. They all have the same objective, that they're all finally trying to tackle on-time execution. I think they all have slight differences. I think with AWP, the unique characteristic of AWP is it's the marriage of front-end planning with field execution planning, whereas things like Lean and Pull are much more solely focused on field execution.
This next question comes from Xavier Wood, and I don't think it's a loaded question, but if it is, you'll tell me. So his question is, he's curious on how InEight currently defines a successful project. What would be the top outcomes of interest?
Gosh, I'm not sure if that isn't loaded. So how do we think of a successful project? So at the end of the day, there are two primary participants in a project. There's the owner organization that they're requiring an asset to be built, and then there is a contractor that executes the work. For me, and I'm certainly speaking on behalf of InEight, but I think a successful project is one where the owner organization receives the asset that is being built within a timely manner, and that timely manner is within expectations that were agreed upon during the outset with the contractor. Likewise, I think from a contractor perspective, and I've seen this personally in my own business over the last 20 years. There is no point squeezing a contractor so hard so that he or she goes out of business, so they're not around for the next project. So, a successful project also needs to take into account the commercial success of the contractor as well. It's the contractor's responsibility to deliver the asset to the owner. The owner also has to play fair and reasonable with the contractor, and, for example, manage things like scope change appropriately, so that the contractor still is successful with regards to their own commercial interest.
Great. This next question is coming from a self-professed subject matter expert in benchmarking. He's very passionate about it. So his question, though, is specifically, what is the potential for learning and using augmented intelligence across the industry?
Fantastic question. So I very lightly touched on artificial intelligence. So machine learning is a subset of AI or artificial intelligence. So if you think of AI, like we alluded earlier, is the ability for a computer to think like a human and make suggestions, then really it's only analogous to a human if it can learn from its mistakes and get smarter, right? Which is something that I think most of us as humans are pretty good at. We learn from mistakes and we improve our reasoning and our ability to make inference. So with regards to planning, scheduling, cost estimating, we've actually invested very heavily in this subset of AI in the form of machine learning, to the point where the computer actually takes into account, when it makes a suggestion to the planners or the schedulers or the team members, if those contributors reject or ignore the suggestions that are being made by the computer actually adjusts its behavior and learns from the fact that, hey, this project is ignoring my suggestions must be missing the mark. And so what it does, it self-evaluates the attributes of those suggestions, and then it goes and re-weights them, makes a subsequent set of suggestions, and then if the audience in turn then accept those new suggestions, the computer goes, oh, okay, they went from a rejection to an acceptance of a suggestion. It looks at the attributes, and again, it's constantly re-weighting each of those attributes, even to the point where it will start to add new attributes that it perhaps didn't take into account. So machine learning is as powerful as the suggestions themselves that are made from AI.
So a related question to that was posed by another viewer. How is AI populated in this context?
Great question. So there are really two scenarios I would suggest. One is, maybe I'm a contractor organization and I have a long history and legacy of projects. Those projects may be good projects. They may also be bad projects, but in both cases, I have the luxury of taking that historical information, throwing it into a knowledge library, and I've effectively digitized my organization's experience. In that first instance there, well, that answers the question. In the first instance, you have that historical knowledge. With younger organizations that perhaps don't have as many projects under their belt, they don't have the luxury of having those historical benchmarks. So what we've done, we've made it very easy, even in the extreme case where we have zero historical information. The first time you use this approach of top-down AWP, right to left, and you're doing the risk adjustment and you're capturing team member opinion, that team member opinion actually automatically populates and is fed into the knowledge library. So in the worst case, which is an extreme example where you have zero historical information, the first time your project team start to adopt this process, and probably more importantly, this software, this solution, the knowledge library actually it's capturing that expertise in real time.
Great. Another viewer asks, when you say AWP is a game changer in terms of planning, what area do you see will have the greatest impact? Or is there a specific area that will see the greatest impact of its application?
My statement was very broad brush. I think from a game-changing perspective, it simply boils down to we have a horrible track record as an industry of on time, on budget, CapEx completion. And so, the metrics that are coming back, even though AWP has only recently kind of jumped from being largely an academic exercise to one that's actually being used in the field, we're already seeing demonstrable improvements that, the 10%, 25% cost and productivity, respectively, metrics that I mentioned to you, they're really hard to argue against. So in my mind, that's the game-changing bit. It's our ability as an industry to accurately predict outcomes. When I jump in my car and go home every night, or I go on a road trip, I type in my destination and the mapping application tells me it's going to take, so many minutes, so many hours. Well, it doesn't get it wrong. It gets it right. Well, project management has got it wrong for way too long.
Excellent. Well, Dan, that's all the questions that we have time for today. And I want to thank our viewers. And I want to thank you for this presentation, as well as our sponsor, InEight. If you have any additional questions or comments, or if we didn't get to answer any questions that come in after, please, we will make sure that we share them with Dan, and he will follow up with answers for you. Also, a handout from today's presentation is available to download from your console. Please visit enr.com/webinars for the archive of this presentation to share with your colleagues, as well as information about our upcoming events. Make sure to tune in back for tomorrow's webinar, Driving Accuracy, Visibility, and Accountability with Drone Data, Case Studies from P-Agnes, airing at 2 p.m. Eastern Standard Time. We hope you found this webinar to have been a good investment of your time. Thank you, and have a great day.